Here at the reproducibility track, our first speaker today is Daniel Wheeler, who will be talking about using Sumatra to manage numerical simulations.
Thank you all for attending my talk. I really appreciate it. For about the last 6 months, I've been using Sumatra to manage my own numerical simulations. And I just want to share my experiences with you about that, about Sumatra. And I'm not a developer of Sumatra. I'm just a really enthusiastic user. I really like it, so that's why I'm here, basically. So I should give some context as to why I'm actually interested in this subject. One of the projects I'm working on is the Material Genome Initiative, and this is actually a White House initiative to better integrate digital data, experimental data, and computational tools for material science, so just improve material science going forward in the future. An important component of that is sort of reproducible research and workflow tools. So that's one of the reasons why I'm here. I'm also I develop a code written in Python called SciPy, which is a finite volume code. It's a PDE solver. I'm also a material science researcher. I do computational material science, and I run simulations all the time. And I myself need a better workflow. I use sort of ad hoc methods to record what I've done, and that's one of the reasons I moved to using Sumatra. So if you were here last year, you may have seen Tim Clem's talk. He really emphasized the importance of automation in what happens at GitHub, and how they've sort of replaced all their human-based process with automated process because of the mistakes they'd found. And that really sort of speaks to reproducible research, and that we don't want to invent human-based process for reproducible research. We have to automate, we have to have tools that automate the process. So we don't want to be like sort of uploading data to a repository and then writing, sort of filling in forms on a website about our data. You know, that's just not going to work. So I'm going to motivate this with a very simple example. This is just to sort of demo the use of Sumatra. This example doesn't have any Sumatra in it. I'm just simply reading in a Sumatra logo, the ping image, and I render that as an array, and then I manipulate the array, and I'm using scikit FMM. So the skFMM is scikit FMM. That's just a fast marching method, a utility in that's available, and solving that to a distance function, and then I'm using a function, and then I'm solving for some diffusion on that new field using SciPy. So the FP is for SciPy, and I'm making a SciPy equation, and I'm just solving. I render the IMG array to a SciPy variable, and then I solve the equation. And so if you do that, you just get, so you read in the image, you get the Sumatra logo. I solve a distance function on that logo, and I get equidistance contours away from the lettering, and I solve a diffusion problem. So this is just a toy problem, okay, to motivate the use of Sumatra. So what does a typical workflow look like when you do it at the command line? So you run the script, you might edit the script, and then you run the script again. And that's how I've worked for years. Well, that's really from the dark ages. Things have improved since then. But so you might edit the script, add the ability to change the coefficient or something, change the diffusion coefficient, and then run it again. And of course, there's no real history associated with that workflow. So in the past, I would have invented a scheme for version control. So I'd have written the files to some directory or changed the name of the files and tried to keep some sort of ad hoc history. But we know there is a better way. We know we have version control. We've got the history of what we've done. And we can query the history. So we have some ability to go back and query the history of what we've done. And so that was really a sea change in the way I worked 5 or 10 years ago when I started to do this for all my research. It was a massive improvement, and it goes a long way to having reproducible research. However, when you do that, with that particular workflow, I just run things at the command line, I save it, I commit it to the repository. I'm not recording the simulation events. So when I run this script, I'm not actually recording that event that took place. So I've changed the coefficient. There's no record of that at all. So what I was doing is then I'd invent a new scheme for recording the simulation. So maybe one particular scheme I've used in the past is where I make a branch just for one simulation, and then I edit the script, I run the simulation, I run the script, get some standard out, maybe a data file, commit that to the repository. So if you do that, you actually have a timestamp associated with that. You have a label associated with that. So it's actually quite a nice system in a way. And maybe if the data file is really big, you could use something like Git Media to store the data file elsewhere and just have a link in the repository to that data file. So that's a reasonable method, but you can see that's not really how the version control system is intended to work. So if you do thousands of simulations, you're going to have thousands of branches. I mean, that doesn't make any sense. And you have no way of querying, for a certain parameter, what simulations did I run? I mean, it's obviously not ideal. So this is where Sumatra can help with this problem. So I'm just going to demo this example script with Sumatra. So to initialize a Sumatra repository, you just call SMT init. You give the repository a name, and then you configure the repository. So you say, what is the important file in this that I'm going to run that I want to record? And with SMT configure, you can also say, well, how do I want to store my provenance data about these events? Do I want to store it in a Postgres database, SQLite, so on and so forth? So how do I run a simulation using Sumatra? Well, once you've told Sumatra what you want to run, you just say SMT run, and then you give a reason, a bit like a commit message. So this is analogous to really using version control, right? Using version control for the events rather than the differences in the files. Okay. So with Sumatra, you have to pass a parameter file. That's unfortunate. It's slightly changing your workflow a little bit, but and on the command line you can also pass parameters. So parameters are special in Sumatra, and I'll talk about that a little bit later. So I've replaced Python script.py coefficient value with SMT run. So if you normally work at the command line, this isn't like a wholesale change to the way you work, right? You're getting to record these events without having to go to some completely different system outside of the way you work. So how do I see, okay, what does Sumatra record, and how do I see the event that I just ran? Well, you can call SMT list, and then you have a label associated with that event. You also have the version of the code that you ran. So the Sumatra repository sits, so you have a .smt file, just as you have a .git file sitting in the repository, and they sit together, and they sort of work together in a way. And so you also have a timestamp associated with the event that took place. Of course, the commit message. You have, it records the location of the .smt repository, but also the remote. So you're obviously going to, of the Git repository, but it also records the remotes associated with that repository. And it records the parameters that are the parameters from the, that you've declared as parameters. And that allows you to search on those parameters later. And also, it's recording the data file and a hash of that data file. So I'm just going to go into the web interface now. The output data file. the parameter file is not recorded. It records the parameters that are in the file. It doesn't record the parameter file itself. You could always commit that to the repository. I mean, so you could record it in multiple ways, in a sense. So this is this is the toy problem, the diffusion problem, with 4 records. Unfortunately, the rendering of the screen has messed up the rendering a little bit, the resolution. So there I've just clicked, so I'll go back. I've just clicked on a label. So that's the label associated with this record, and I click on that, and there's the various fields that are recorded with this record. So you have some general information. You've seen that. That was with what you get from the SMP info. And of course, you can change that in the web interface. So you can change the reason. You really shouldn't change the reason, because that was, you should do that before you launch a simulation. And the outcome, so you really have sort of 2 commit-like messages that are associated with the record. You should give a reason and an outcome. And of course, you can tag. So if you launch batch jobs, whatever, you want to tag those as batch jobs. And the output files are also recorded. So the location of those output files. Obviously, the output files are not recorded in the database, but the location is recorded, and the hash associated with those files. And parameters are recorded, so that allows you to go in the future go back and search. So, I mean, one of the issues is, how do you know what is a parameter and what isn't a parameter? And that's an open question. You don't always know a priori what your parameters will be. And of course, you don't have to. I mean, these can change for every simulation. You can change what the parameters are. So, and of course, it records the dependencies, both those in my virtual env that I ran this in, and the site packages. And if you look, there's 3 shards here from various Git repositories that I'm developing those at the same time I'm doing my research. So we often find ourselves in this situation where we're doing our research, but at the same time we're developing other people, developing code or hacking other repositories. So you need to have that recorded along with the. So you need the version of the repository where the research is being done, but also the versions of the code you're hacking. So it does that, which is really nice. And of course, it's standard out, standard error. And hopefully this will show on this resolution. I'm not sure, but you can compare records. Fortunately, it doesn't show up very well on here, but if you have a full screen, you can see they sit side by side. And it also shows the ping image associated with. So I've associated a ping image with this record. So if I click on here, and of course you can see the image. It's nice. The other thing, so say I was working on I'm hacking away on another repository that this code depends on, and I forget to commit it. Oh no. Then those changes are not saved. But so here I've hacked SciPy. I forgot to commit that, and then I can check the diff. Oh, for some reason it's not. Anyway, it should have the differences there between the changes you made and the last revision that you committed. But for some reason it's not there. But if it works properly, it's there. So anyway, so that's the web interface. So let's go back to the talk. So what is the sort of general overall health of Sumatra? These are the commits per month. So that's on the increase. It's not a huge amount, but it's on the increase, which is quite good. And the contributors are also increasing. So that's a good sign. So this is Andrew Davison. He's the main author of Sumatra, and he's been really helpful. So he's based at CNRS. He leads a neuroinformatics group. He models neuronal networks. Most importantly, he's really into reproducible research. He goes to conferences all the time, so he seems to have his finger on the pulse of what's happening in reproducible research, and that's that's important. You know, it's good to see that in the developer of this. He develops a whole load of packages. And most importantly, he uses this every day for his own work. We all know that's a good thing. So what are the issues with Sumatra? Well, one of the issues was concurrency. If you launched a number of jobs at once, it would crash the SQLite database. I submitted a patch recently to update to Postgres, and that has improved things considerably. Also, we want to be able to inspect jobs that are running. We can't currently do that, so you can't see the jobs that you've launched with Sumatra. That's by default is only recorded at the end of the simulation. And it doesn't work well at the moment with queuing systems. See, it doesn't use a queuing system to inspect jobs, parallel and distributed and so on. And we need better housekeeping in Sumatra, documentation, less state being held, and better tests. So this is an active research example that I'm working on. So this has 867 records in it, so it's quite large. This is in SQLite at the moment, so it's almost impossible to use. I've got to transfer this over to Postgres. So what I wanted to show here was where let's go to the notebook. Okay, this is just an IPython notebook where I'm pulling out records. I'm pulling out the records based on parameter values. So where you have the CFL and the numbers, I'm pulling out the records based on CFL number, and then using those records to plot some images from the simulations, and then I have this little thing, SMT IPy table, which plots a nice HTML table in IPython. So you have the images, and you have the table with the record associated with those particular simulations that created those images. So that's, I mean, in the past, I was doing this all by hand in a track blog with restructured text, filling it in. Now this is all automated. It's really changed, improved things for the way I work. And if we just look at the code for this here, that's all the code I needed to pull out those records. So I pass in the parameters. I say, are those parameters a subset of a particular record? And then just dump those out, and I have those records based on parameter value. That's it. That's all I needed. So that's just rendering it to a blog. It looks, the HTML table looks okay. And of course, you can always use the API with Sumatra. So you can create a record, run your simulation, save your record out. You don't have to use the command line. You can get creative. You can do anything. You have a great deal of flexibility there. This is some of the future work that I think is important. Certainly, testing is really important. Sumatra could play a role in testing because you have those records, and you say the particular records are really important, and going forward, I want to maintain those. So you could integrate that with BuildBot. I think that would be a powerful way to maintain records. So to finish, Sumatra is a lightweight system for recording simulation events, and you don't require any significant changes to a typical command line workflow, right? So that's for me, that's really important. I don't want to go into someone else's GUI and to do a workflow. I want to be at the command line. And you can find anything about Sumatra just Googling Python Sumatra. Thanks. Go ahead. So yeah, the question is, do you get access to all the Sumatra API? Yes, I would say that's, yeah. I mean, Yeah, so you can look at the record, and then you can look at all its attributes and so on and so forth. Oh yeah, yeah. You don't need the web interface at all. No, the web interface is sort of an additional thing.
So in your example, there was one script that was so what if you were doing analysis work and there were more than one script? Would like you had to configure, declare a script, and you have to reconfigure, or you sort of switch from one script to another?
Yes, you have to reconfigure. So the question is, if you're doing analysis, you have like maybe a pipeline of you running the script, then you want to view things. What do you do? So Sumatra is limited. Let's just say that it's not like a pipeline tool where you can link all these stages together. It's doing one thing. It's doing one thing well, but it's not flexible in that sense. So yeah, if your post-processing is in your script, then sure, that's fine. But yeah, I mean, you get into hierarchical records and all this type of thing. So it's not. I don't think that's a trivial problem. So the question is, can you have multiple instances of Sumatra in one directory?
No, not in one directory, but it has sub-projects, or it knows rather than doing multiple different parameters for the same, not for the same data, you have like different input files. How does it expand, or if you have one project over here, one project over here? Does it play well with itself?
Well, you can. I think you can load in multiple projects. So one Python instance. Obviously, you could pull in multiple projects. So if you load a project, you can give the path to the project, and then that's all you have to do. So yes, you can in one Python session you can pull in as many projects as you want. Yeah. So the question is, if you're editing the script and rerunning, well, that's the whole point. Is that yes, you edit the script, you commit it's sitting in a Git repository. You commit that script. Sumatra won't run until you commit that script. So yeah, you can do anything you want to the script. It doesn't matter.